Okay, in exercises 97 through 102, the velocity function in feet per second is given for a particle moving along a straight line. Find A, the displacement, and B, the total distance that the particle travels over the given interval. So in these problems, we want to first recognize that we're working with the velocity function. And the velocity function is the derivative of the position function. In this case, we'll call it s of t. So v of t is s prime of t, the velocity of the position function. And when the velocity is positive, the particle is moving to the right. When the velocity is negative, the particle is moving to the left. When the velocity is 0, the particle is at rest. So these are the first three most important things to remember about motion and about the velocity function and what it tells us about the motion of the particle. Next, we want to define displacement, and displacement is what I'm going to call net change in position. You may have traveled halfway around the world, but if you end up 10 feet away from where you started, then your displacement is simply 10 feet. So displacement is your net change in position. That's the difference between your end position and your beginning position. So let's do it this way. It's your position at the end of a time interval minus your position at the beginning of the time interval. It's just your net change in position. And you might note from this that s of b minus s of a, well, that's exactly what the integral from a to b of v of t dt is. Remember, we find the antiderivative evaluated at the upper limit. The antiderivative of velocity is position. We evaluate at the upper limit minus evaluated at the lower limit. So that's what displacement is. It's simply the definite integral from time t equals a to time t equals b. Total distance traveled, however, is different. If I move 10 units or 10 feet to the left and then came back 9 feet to the right along the straight line, so if I start at this position, move 10 feet, then turn around and move back 9 feet, then my displacement is 1 foot to the left. I could say it's negative 1 foot. I'm 1 foot to the left of where I started. However, my total distance traveled is going to be 19 feet. So that's the difference between displacement. Displacement is just how far you end up from where you started, and total distance traveled is the positive yardage that you travel in any direction. So if you move 10 feet to the left, then that's 10 feet total distance traveled. If you come back 9 feet to the right, then that's 9 more feet total distance traveled, for a total of 19 feet total distance traveled. All right, so let's take a look then at the first problem here. And so we start with the function 5x minus 7. We're interested on the interval from 0 to 3. So I set my window to be x is 0 to 3 by 1s, negative 10s to positive 15s by 2s. And if I go and graph that, you're going to notice that with this velocity function, some of the velocity curve lies below the x-axis and some of it lies above the x-axis. So I've gone ahead and put a copy of that graph onto our screen here. So what we want to see is that for this part, the particle is moving to the left. Here, the particle is moving to the right. And it should be then that at the place where the velocity is 0 and it changes from left to right, the particle turns around. So we do say also that the particle is at rest as it's turning from left to right. For that brief instant of time, it has stopped its motion. It's no longer moving to the left, nor is it quite moving to the right. For a brief instant in time, it stopped, and then it begins to move back to the right direction. So this is what's important in looking at the velocity curve there. All right, second of all, let's see that if we were to take the area between the velocity curve and the x-axis when the velocity is negative, that's going to tell us the distance that we moved to the left. So integral of v of t dt. And how do we know where that occurs? Actually, all we have to do is come in here and solve 5t minus 7 equals 0 to see where where the x-intercept is. 5t equals 7, t equals 7 over 5. So let's say that that is t equals 7 over 5. All right, so what we want to do then is, if we were to find the integral from t equals 0 to t equals 7 over 5, then that should give us the distance that we moved to the left. And so let's see, what is the antiderivative of 5t minus 7? It's 5t squared over 2 minus 7t, and we want that from 0 to 7/5. And we plug in, and we're going to get 5 times 7/5 squared over 2 minus 7 times 7/5, and then when we plug in 0, we're going to wind up with 0. To save us the time here, this turns out to be negative 49 over 10, or negative 4.9. And we can illustrate that by now using the calculator or we can confirm that by now using the calculator to find the area under the curve, or between the curve and the x-axis, for the interval on which the velocity is negative. So I'm going to come back to the calculator, second calc, option 7, and I want to go from 0 to 7 divided by 5, and I end up with negative 4.9 as we had stated there. So the integral from 0 to 7/5 tells us how far the particle moved to the left. Alright, so the particle moved 4.9 feet to the left in the first 7/5 seconds. Then the velocity becomes 0 and it changes from negative to positive. So this time, the area between the curve and the x-axis that lies above the x-axis will tell you how far the particle moved in its motion to the right. And that would be the blue area there. All right, so we would calculate this similarly. We do know the antiderivative already. That's 5t squared over 2 minus 7t for t equals 7/5 up to 3. And we can plug in t equals 3 there. Now this time we don't have a 0, so the quantity on the right is not going to zero out, but we do know what that quantity is already. That means that would just be 5 times 7/5 quantity squared. This is exactly what we calculated up here. And so we know that that is negative 49/10 or negative 4.9. So when we carry this all out, I'm just going to jump ahead to the answer. This is going to give us a positive value of 1.5. An area of 1.5 plus 4.9, which is a total of 6.4. And so what this tells us is the particle moved 6.4 feet to the right from t equals 7/5 to t equals 3 seconds. Alright, now again we can confirm this using the calculator, so let's bring that in. And I'm going to clear draw second program, option 1, clear draw, and this time I'm going to find the integral from 7/5 to 3, and you should see that it's 6.4. Alright? Alright, so let me just note on our diagram here that this was negative 4.9, the red area. The blue was positive 6.4. And so what that means is that, just like our diagram previously, we started out at a point, we moved 4.9 feet to the left. We turned around and moved 4.9, then we moved 6.4 feet to the right, leaving us with a net change in position of positive 1.5 feet. And that's our displacement. So two things here. Displacement equals 1.5 feet. Total distance traveled equals 6.4 feet. Sorry. The total distance traveled is going to be the distance that you move to the left, which is 4.9, plus the distance you move to the right, which is 6.4, which is 11.3. All right, so that would be the answer to this question here. Now, what I'm going to do first of all is show in one integral that we can find the displacement simply by taking the integral from the left to the right, regardless of where it's positive or where it's negative. So I come back to my graph. I'm going to second program, clear draw, and this time I'm going to find the integral from 0 to 3, and we will see that it's going to give us 1.5, which is the net change in position relative from where we started from. Now, if I wanted to show how I could get the total distance traveled, I'm going to make a slight change to my original function. I hit second, delete, which is insert. I'm going to go to the math key and then to absolute value, and this time I'm going to graph the absolute value of my function, and you'll see that the part that was negative has now been reflected over the x-axis so that as if it were positive. And I'm going to take the integral from 0 to 3, and you should see that we're going to get 11.3 as a total distance traveled. So I'm going to stop at this point and we'll continue in the next video.